Lesson, we're going to be talking about classifying triangles. And triangles are one of our polygons. So if we're looking at triangles, we actually classify them based on some attributes. Now, an attribute, if you're not sure of what that means, are characteristics of a figure like side measurements and angle measurements. So let's look at an example here of how we're going to use an attribute to determine a triangle. So the Hammond family traveled from Columbus, Ohio. So they start up over here in Columbus. They're going to Texas, and then they go to Atlanta, Georgia, before returning home. So in this route, they have made a full triangular travel plan. So the distance of each flight is shown on the map. Find the number of congruent sides. Oh, well, there's another fun word, congruent. Congruent means they're equal in length. So the length of the sides of the triangles are 924 miles, 573 miles, and, well, I need to find that last distance. And I see that it is 729 miles. So if I look at all three of these distances, are any of them the same number, the same value, the same distance, or the same measurement? And no, they are not. So how many of the sides are congruent? None. So we could say 0. All right, so when we classify triangles based on length measurements, we categorize them in one of three ways. The first one is isosceles. An isosceles triangle has at least two sides that are congruent. So when I look at an isosceles, I have this leg and this leg here, well, or these sides really, 3 and 3. And so I'm going to use a little hash mark, and I'm going to use 1 on each of those. And since I have 1 on each, that means that those are the same. I'm going to put 2 hash marks on the bottom triangle side because it's 2 inches and it's a different length, right? I'm not putting 2 lines there because it's 2 inches, but just to show that this is different than those other 2 sides. So isosceles have 2 sides that are congruent and 1 that's not. If you think of if you isolate somebody, they are off by themselves. Well, I've isolated this 2 down here and it's off by itself. It's not matching, it's not congruent with the other 2 sides. Now we have equilateral. Now, hopefully you identify that equi in here means that all sides are equal, all sides are congruent. So I can draw a single line on each of these sides, one little hash mark, showing that each side is the same since they all have the same number of hash marks on that side. And then we have scalene. And scalene is that no sides are congruent. So just like this picture up above of our map, no sides were congruent. No sides were equally to each other. So this would be a scalene triangle up here. So no sides are congruent. So if I want to draw my little hash marks, I'd say, well, that's 1 hash mark. This would be 2, and this one would be 3, showing that no sides are the same. So the triangle found in the map, we already answered this, is scalene. And we spell scalene S-C-A-L-E-N-E. Always refer back to the book and what you see to be able to spell it correctly. All right. Next one is we are looking at the pyramids in Egypt, right? And so we're determining the number of obtuse, and right angles. So those are fun terms. So let's first identify what those words mean. So acute. And I know that some of you guys may think, oh, acute, like, oh, that's so small, so itty bitty, so precious like looking. Well, same kind of idea, but really we're saying that an acute triangle means that all 3 angles of a triangle are less than, so they are less than 90, and we have in angles in geometry, we use degrees to measure that. Kind of like in distance, we call it feet or inches or miles. Well, with geometry, with angle measurement, we use degrees. And I'm going to abbreviate angles quite a bit, and it's something that I encourage you to do as well, is that you can draw an angle and have it kind of be this little line with this little, or this angle kind of looking like shape. This means angles. Um, So if I could say that, well, all three angles are less than, oh, let's draw that a little bit better. Um, so we would say that all three angles are less than 90, right? Now, a right triangle means that it is a right angle. And a right angle, we can see based on this little square-like identification in the corner here. That means that it is 90 degrees, right? So equals to 90 degrees. So if I have one right angle, the entire triangle is a right triangle. It doesn't matter about the other two. This one's going to be 90. Now, our last triangle that we classified based on angles is obtuse. And obtuse is essentially the opposite of acute in a way that acute is less than 90. Well, that means obtuse means that we have one, not at least. We have one angle that is greater than 90. So we have an angle that's greater than 90 degrees. So if I'm looking at this, well, I could identify, well, if I had 90 degrees here, this angle here would be less than 90. If I look at this one here, that one here is less than 90 as well. So that means that this one would be my obtuse angle, right? So the entire triangle then is obtuse. Now, is it possible to have two obtuse angles? Interesting thought. We'll come back to that later on, but I'll let that kind of think or let you think about that. So the triangle in example 2, if we're looking at our pyramid here, how many angles of the triangle are acute? Well, just by looking at it, we don't need a protractor to really measure it. I could identify just kind of eyeballing saying, oh, well, if this was 90 and this is 90, and even if I were to draw this one out at being 90, that this would be a 90 degree. Well, how many angles are acute? All three. Are any obtuse? None. And are any a right angle? None. So this type of triangle here would be acute. Now, if we really want to make a combination, we could refer to it as an acute, well, equilateral would have to be acute because all triangles have 180 degrees, right? Because if I have 180 on an equilateral triangle and I divided that by three angles, because all triangles have to have three angles, well, an equilateral triangle has all three angles equal to 60 degrees. So an equilateral, all three of these angles in here are 60 degrees. Each one of these would be 60 degrees because 60 times 3 would be 180, just like 6 times 3 is 18. All right, so let's do a couple practice here. All right, so classify the triangle based on its sides. So if I see I have, well, this top length here is 4, this one here is 2, and that one's 2. So I can put one little hash mark on there. And it's very important at this point, guys, in geometry is that you make sure you read the directions that I am classifying it based on its sides. I hope you identify the words that we're using here based on its sides. So that means I'm going to use, well, how many sides are congruent? I see that it has 2. So it would be an isosceles triangle. An isosceles triangle because I have two sides that are congruent. One is off by itself, so it's isosceles. Classify the triangle based on its angles. Again, we make sure you read it based on what? Its angles. So this triangle, if I'm looking at it, I want to be able to eyeball and say, oh, well, if I were to draw little hash marks here, well, that's less than 90. This one, you should be able to see, well, that's less than 90. And even if I had this one here, if I drew this out and continued on, well, this one's less than 90. So this one is an acute triangle. All right, so let's do some practice as well. So determine the number of congruent sides for each triangle, then classify the triangle based on its sides. So if I'm going to look at this, how many congruent sides do we see? Well, I see 2.9, 2.5, and 1.3. None of those are the same, so it has zero congruent sides. So that means, oh, based on its sides, so that means that this is scalene. All right, and let's change up our color in here. And let's look at this next one. How many congruent sides do I see? Well, I see 2, 2, and 1.5. So these two sides are the same. This bottom one is not. So I have two congruent sides. So this is isosceles. All right, classified based on its angles. Now, I know that we don't have a protractor to measure it, but if I'm looking at this, again, this one should look somewhat familiar. If I'm looking at these two sides, these two corner ones here, these two are less than 90. This one here, I know it looks a little close, but if I were to draw a 90-degree angle in here, this would be obtuse. All right, now if I look at this next one, again, if I had a 90-degree angle here, this would be, so that's 90. So that purple line that we see of the triangle, that's less than it. Same thing if I were to draw 90 degrees here, well, that next one is less than 90. And again, if I were to draw another one here, well, that's less than 90. So this whole triangle is acute. And the giveaway on this one on number 7 is I see that right angle symbol in the corner there. So this triangle is a right triangle. And number 8 here, I should be able to look at it and it looks pretty congruent on all three sides. So it's an equilateral if I do identify it that way. However, we're doing it based on angles. So this would be acute. All right. I hope this helps break down how we identify triangles based on sides and angles. Remember, sides, we are calling them based on their characteristic, their attribute that we use for a side. Isosceles means that we have two sides that are congruent. Equilateral, all sides are congruent. Scalene, no sides are congruent. All right. And then for angle classification, acute means less than 90. A right triangle means that we have an angle that is equal to 90. And obtuse means that we have one angle that is greater than 90. So that whole triangle then is obtuse. All right. I hope this helps identify how to classify triangles based on sides and angles.